One?
Hi, good evening, everybody. So we are the team Go Pick. I'm Will, and he's my team member Howard, Paul, and Joseph. So for this data exploration datathon, we choose the challenging one, which is providing the personalized recommendation for the online retailer. So after exploring the data set, we deleted a lot of irrelevant columns. And we after exploring the data set, we choose the product category name as our output, and all the other variables that we reserved as our input to predict on the Y variables.
After we narrow down the columns, and those are the columns that we find null values inside. And among them, most importantly, is a review score and a common message. We consider review score as directions, and the common message is magnitude. If a review score, if we find a null value, we consider this 5 because there's no complaining about this product. And we use 3 as our threshold. If it's above 3, we consider positive comment. If it's below 3, we consider as negative comment. And for common message, we consider as magnitude. We use the common message length as the magnitude of how strong this comment is. And we find the median for common length is around 54. So if its length is above 54, we consider strong comment. If it's below 54, we consider as weak comment. And then combine score and comment message together, we have a strong positive comment or strong negative comment.
So next part, we want to use a heat map for the product category name. So basically, as you can see, we want to investigate, are there any correlation between the product category name and among the other variables, and we can see there's very weak correlation relationship. So we assume there probably a lot of redundant variable. That's why we want to further investigate using the PCA.
So we use PCA to shrink the variables we committed, and we choose the first 2 principal components. The first principal component is highly negatively affected by the zip difference. So we interpret it as you have lower zip difference, means that sellers and customers are nearer with each other, and the delivery time will be shorter, and the customers will have a better experience. And also in this way, maybe this model can help promote local business and decrease CO2 emissions, things like that. And it's also positively affected by product weight because we think the customer's preference and their demand on products is highly affected by the weight. And the second principal component is also positively affected by product description, as we think that it's because that if the product has a more detailed description, it's more likely to get customers to be interested and purchase this product. We first train a logistic regression classifier, and the accuracy is only 6%, so it's definitely not good. So we turn to train a random forest classifier, which is a group of decision tree to make this classification problem, and the accuracy is now 85%, and we find it satisfying.
We think the product weight shouldn't really be affected into our model because it only affects certain categories such as foods and furniture. In the previous model, it affects that much. It might be due to customer buying habits in Brazil. So we're going to remove product weights in our next model.
So we'll do the PCA again, and without weight, the description length just becomes the most influential variable to the first principal component. And we train the random forest and find the accuracy dropped from 85 to 66, but we find the prediction just be more reasonable to us. In conclusion, we train a random forest model to be our base, to be the foundation of the recommendation system, which will help us to promote product categories to our potential customers.
Thank you so much. This is our team. Go Pick.